Actually, when you write this kind of things, when you define this library, it means that you can write this kind of syntax. So these ports are STD logic, are logic ports. So the name of the port, the input or output actually is the direction, and here it's output. Okay, sorry, it's type. And here how many output we have? One, f. So we define another variable, the name is f. This is output or input. Okay, definitely it's output. And what's its type? STD logic. So both of them, STD logic and STD logic, but this one is the input and this one is the output. And the name of the output is f, and the name of input is, the name of input are actually x0 to x3. It's up to you, you can define different name here, it's up to you, but I'm going to use the same things as you. After that you finish your entity. Again, I'm going to tell you, don't forget the semicolon, semicolon, semicolon. And after that you should define your architecture. Actually each entity can have many architecture, can have one architecture, two architecture, or three architecture or more. Here for this function we just use a one architecture. So we write the keyword architecture, here the name of the architecture and the keyword of, and here must be the name of your entity. You can see my name, my entity names is lab6, so we must write here lab number 6. If your entity name is, for example, Ali, you should write Ali here, you should write Ali here, and you should write Ali here. And another keyboard is. So here we have three keyboard, one of two, and also this one has three. And here must be your entity name, and here must be your architecture name. And if you check here, your architecture is from here to here, and at the end of architecture you should write the end architecture name. You can see the name architecture net netlist struct is the same as here architecture netlist struct. So the name of the architecture is up to you, but it must be the same here and here. After that you should write your signal. They are output, they are input, this is the output and this is gate, but you have some line here that connected this gate, the output of this gate, to input of this gate. They are signals. Okay, they are not input, they are not output, they are signals. So you have something like input, you have something one or two or more output, you have something as a gate, and the line that connected to gate, input of one gate to the output of the another gate, it will be the signal. How many signal do we have here? 1, 2, 3, 4, 5, 6, 7. The name of the signal is up to us, but I try to do it like this, and you can do it the same. So we define our signal, write the keyword signal, and this is the name of the signal, 1, 2, 3, 4, and blah blah. And don't forget to use the comma. You can see this is the comma between them. And also after that you should write your signals type. The signal type will be STD logic. So you can see the signal type is STD logic, your input here is STD logic, your output is STD logic. Okay, that's why we use this library. After that we define our, for example, up to here we define our signal, we define our input, we define our output, and here we should write our function, begin and end. So between these two, begin and end, you can write your function. Okay, let me write our function. This symbol is for the assignment. It means that everything in this area will be assigned in x3l. Okay, so here, for example, we have a not. It means that we are going to work with the not gate, and yes, in the not gate here we use the gate not, and the output of this one will be in the x3l. Okay, let me check the circuit. Yes, this is the not gate, the not of the